In this math talk, we build on what we learned through our discussion of multiplication of integers, and we extend it to division. And so we say, how do we extend multiplication of integers to division? And it goes something like this. Our question is, positive 24 divided by negative 8. What would the answer to that be? And you might already have kind of an intuitive grasp of that based on what we talked about in multiplication, and that's great, but just hold and watch what I do here, and hopefully it will align with what you think should be the correct answer. So the first thing I want to do is just revisit what we looked at, which was positive 24 divided by positive 8. Now we know positive 24 is just 24, and positive 8 is just 8, and 24 divided by 8 from our multiplication facts is just positive 3. Now what follows from that is a multiplication pairing, which looks like this. Positive 24 is in fact the same as positive 8 times positive 3. If we want to get fancy with some language, we're really saying that the dividend is equal to the divisor times the quotient. The dividend being 24, the divisor being 8, and the quotient being 3. And that's always true. So if we go through that thought process, we could say, okay, positive 24 divided by negative 8 is some mystery value. And so we go to the idea of this notion that the dividend is equal to a divisor times a quotient. And we're just trying to figure out that quotient. In other words, the answer to the question. So we have positive 24 must be equal to negative 8 times something. Well, we know from our integer multiplication that negative 8 times negative 3 would give us positive 24 because two negatives multiply to give a positive. So that would have to be negative 3. So our division answer must have a value of negative 3. So positive 24 divided by negative 8 is negative 3. Well, now that looks awfully consistent with what we were talking about with multiplication. We said that two positives multiplied together give you a positive, two negatives multiplied to give you a positive as well. If the two numbers being multiplied are opposite in sign, negative positive or positive negative, we get an answer that is negative. Well, it probably comes as no surprise, given that multiplication and division are opposite operations, that there are some connections between them. So in fact, in division, we have that two positives divided result in positive, two negatives divided result in a positive and a negative divided result in a negative, and a negative and a positive divided end up in a negative. So just as before with multiplication, we get this result. When dividing or multiplying, and I underline two integers, if the signs of the two integers are the same, the result is positive. If the signs are opposite, the result is negative. So that works whether it's division or multiplication. And that's great news because it's not a separate set of rules that we have to remember. Okay, let's try some questions. So we'll evaluate positive 8 divided by negative 2. Well, right off the bat, I see that a positive divided by a negative, because the signs are opposite, will result in a negative. All I have to figure out is the 8 divided by 2. My answer is negative 4. Negative 30 divided by negative 6. Now that I'm dividing two numbers with the same sign, my answer has to be positive. 30 divided by 6 is 5. So my answer is positive 5. So now this one is a little bit more complicated. We've got 8 times negative 5 divided by negative 10. We understand that that 8 has an understood or an implied positive sign in front of it. So it's a positive 8 times a negative 5. Well, I have to perform that operation before I perform the division. The positive 8 times the negative 5 gives me negative 40. And I'm dividing that result by negative 10. Well, a negative divided by a negative has to be positive. 40 divided by 10 is 4. So I write positive 4, or just plain old 4. So let's try something a little bit more complicated. So we're going to evaluate for m equaling negative 3 and n equaling negative 4. So there's a little bit of algebra in this where we have to perform some substitutions. Well, our first step is to recognize that m is going to be negative 3, n is going to be negative 4. Any place I see m, I'll replace it with a negative 3. Any place I see n, I'll replace it with a negative 4. So my first line looks like this. 2 times negative 3 plus 6 times negative 4 all over negative 4 subtract 3 times negative 3. Okay, so we've got a number of things that we have to deal with here. Starting with the numerator and the denominator, working with those separately because they have to be worked out, I work out the top to be 2 times negative 3, which will be negative 6, plus 6 times negative 4, which will be negative 24. On the bottom, my negative 4 stays as it is, and my negative 3 times my negative 9 becomes positive 9. So I have negative 6 subtract 24 over negative 4 plus 9. I need to work out the numerator and denominator still. Negative 6 subtract 24 is negative 30, and the negative 4 plus 9 is positive 5. Now I'm down to negative 30 divided by positive 5. And that leaves me with a negative divided by a positive, 30 divided by 5. We must end up with a negative 6. So that's really all there is to it. Thanks for watching.